Okay, so we're going to step through the Splice Machine sandbox and kind of how that launches and where it starts from and what it's doing as it stands things up. At this point, we're going to, we'll get started here at the community.splicemachine.com site and kind of jump into the getting started page here. And from here, we're going to choose the sandbox cluster generator, and this is going to get us set up to spin up a cluster on AWS. So let's jump in here. Fill out the form with all the necessary information. Maybe not. All right, agree, move on from there and get into the fun part. All right, so from here, it's going to ask us for some information. Real simple stuff. What do you want to call this thing? We're going to call this super creative. We're going to make this relatively small. So in this number here is the amount of data you expect to load into your cluster. So this is based on the size of data that you're looking to test out, not necessarily the size of the cluster. We actually do a little bit of calculation on the back side of this and make sure that we size this cluster appropriately to hold the amount of data that you're looking to work with. So in this instance, we're going to go for about a terabyte of data overall. So we'll choose 1,000 here. And then we are going to go with a relatively small cluster for this generator. So we'll go with just 4 region server nodes. And then our key pair is something that we set up in our AWS account. So once you have an AWS account set up and you're getting ready to launch some EC2 instances, one of the first things you'll have to do is create an SSH key pair. What we can do is real quick while we're here, we'll jump back over to the AWS UI. We'll see here that I'm logged in. I've got nothing running at the moment. I'm in the Oregon region and I have 1 key pair. And what's this look like? If we jump over to the key pairs, we'll see that we have a key pair called vSplice dev. It's got some neat information here. There are 2 ways you can get a key pair. You can click the create button. It'll generate something for you, allow you to download that private key file and have it accessible to you. Or if you have an existing key, you can actually import it via this UI. We're not going to step through that today, but just wanted to kind of have a reference there so we understand what we're working with. We know that in our Oregon region, this key is called vSplice dev, so we will just copy that and we'll dump it right here. Next thing we want to look at is the EC2 instance type. Generally speaking, we run Splice Machine on some fairly heavy-duty nodes, so our options here are pretty limited because we do want to make sure that when you're running Splice Machine, you're not going to be bumping into hardware limitations. So given that, we've come up with a list of instance types that we think are appropriate to run our stuff on. In this instance, we're actually going to go with an M4.4x large. That's probably my favorite sort of middle to low end node that we can run on, and everything runs there very comfortably. From that point, we'll click submit. This is going to go off on the back end and do a little bit of kind of PHP web server magic and generate a template for us. In the process, I'm sorry, go ahead.
So there is no relation between the data being loaded, the number of cluster nodes, and the configuration.
That's correct. Those are all independent parameters that you can choose as you generate the template.
Okay, thank you.
So, what about the replication factor? Say you have 1 terabyte of data, and you would like to have a replication factor of 3. Shouldn't we just put it as 3 terabytes?
No, absolutely not. So the way this sandbox is generated is we do that math on the back end. So the input value there is the amount of data that you would like to load. So if you have 1 terabyte of raw data files, that's the number you would input there. There's no need to add any buffer space. We actually do that on the back end. To be very specific, we use a multiplier of 5, and that is to account for HDFS replication, landing zone for import files, and then overhead space so that the moment you load the data, you don't have HDFS complaining about being low on disk space.
And I also saw that you're not choosing any compute nodes. You're choosing memory intensive nodes. Was there a reason for it? I know you said it's your favorite.
So generally speaking, the relationship between compute and memory on the M series nodes works out well. So this is a 16 vCPU, 64 gig machine. To get to a 64 gig machine on the compute intensive nodes, you're going up to a C4.8X large, which is a little bit more expensive and has 36 cores on the machine, which is a little beefy for us when you look at memory to CPU core ratios, which is why I like that M4 a little bit better.
Thank you.
All right, so from here, our next thing is, so this on the back side, it generated this template file and dumped it out into S3 for us. So here it is, and we're gonna look at that in just a second. Before I do that, you'll notice the next couple of things that'll happen here. We'll be able to choose a region. Obviously, we're gonna default to US East 1 because it's the most popular with Amazon. In our case, we're gonna use West 2, and then we would click the Launch Cluster button. Before we do that, though, I do want to take a second and pull down this JSON file and take a look at it, because the one thing that's neat here is you don't have to go directly from here to launch the cluster. If you are very interested in what we're doing on the back end, this is a file that's accessible. We can download this file, we can look at it, you can tweak it to your own settings if you like to, or to fit your environment in AWS, and actually use that instead of what we generate here. So let's take just a second and pull that down and take a look at it. So we'll do that over here. So we'll download this file real quick, open it up. So in here, we can see that it's a JSON file. Inside of CloudFormation templates, there are lots of different things that can be used here. A couple of things that we do inside of this template is we do create some mappings. These mappings help us make this template region agnostic. So basically, depending on what region you launch into, we will spin up the proper CentOS AMI. We will set up the proper DNS mapping for the VPC that gets created. We've got a template here for the private IPs that are used inside of the VPC that's created. And then here you can see these are some of the variables that we actually set up when we went through and generated the template. We can see the instance type that we picked, the M4.4X large. We can see the key name that we specified for the SSH key pair. And then here we see the data disk capacity. So what this is, this 313 works out to our 1,000 gigabyte data set multiplied by our multiplier, and then we divide that by 4 disks per cluster node that we've chosen. And at that point, our little calculator comes up with 313 gigs per data disk. And if we scroll down here just a little bit, we can see some more interesting stuff. Here's a little outputs clause inside of this CloudFormation template. What that's going to do is when this template is created in AWS, there will be an output section in the AWS web UI that'll help us get a little bit of information about our cluster, how we can get into it, how we can get a hold of it without having to go dig through the list of instances we're running. Further down in this template, we get into what we're actually doing inside of AWS. So we create a VPC. Along with that, we create the kind of necessary things that go along with it: a subnet, an internet gateway, a DHCP options set, an access control list, and a route table. And then beyond that, we move into the actual instances themselves. The instances aren't super exciting, but there are a couple things I do want to talk through in here. One is you can see we've got the volume references here. The volume descriptions come a little bit further down in the template. We also see the mapping to the EC2 key name, the EC2 instance type, and the actual AMI that we're using depending on the region that we're in. You can also see here that we create each instance with a 100 gig root volume. So the root partition is 100 gigs. That is so that we have enough room to install and deploy the Cloudera parcels that we'll get to here shortly. A little bit further down, this is a little piece of, I won't call it magic, but this is part of the automation that's in place here to make this all work. This user data section leverages a technology that's called Cloud Init. And what it'll do is as the instance spins up, before it's fully booted and installed, it will run a couple of scripts. And that'll help move us forward a little bit and prep us to actually get the full cluster software and Splice machine installed. You can see here, we download a couple of files. There's a shell script that comes down. There's also a tarball full of some additional scripts that get the Linux environment set up to fit within sort of the Hadoop ecosystem and make sure we have all the right Linux level settings configured. From there, we actually extract some of those scripts and then execute them, and that all happens as part of that first boot. And then we can, if we scroll down a little bit further, we kind of repeat this pattern for each one of the instances. You'll notice if you're looking real close that the worker or sort of data node instances have a different setup script than the master node. That is by design because the master node will get Cloudera Manager installed where the workers will just be client nodes within the cluster. Jumping down towards the bottom of this template, we'll get into some of the other little things that get created here. Here we can see all of the individual EBS volumes that we created, all the little 1313 gigabyte volumes. Each one of those has a reference and a name, and those are all referenced by their individual instances. And you can see here the callback to the data disk capacity parameter that we have specified up towards the top. And then lastly, the one thing I want to touch on here, and this is something that ultimately you might want to modify before you launch this template. And this is these two lines right here. These are the ingress rules for the security group on this VPC. So two key things here, and this is by design, though not super secure. The goal here is to make this very easy to access and easy to work with. In doing so, we've sacrificed security to a large degree. What we've done here is each one of these EC2 instances gets a public IP address, and then within this VPC, the security group is wide open to everywhere. And so right now you can see the two ingress rules we have here for the security group are everything within this specified subnet. So this 10.250.0 subnet where all of these instances exist. Obviously we can do full access throughout all the instances. And then the second piece is that anywhere can get in. This is, again, not ultimately desired, but in the interest of not having an easy way to tell what anybody's IP is, we kind of went this route. And you'll either want to edit the template before you launch or right after everything stands up, go and edit those security rules to ratchet that down to where you're only accessing from places you want to be able to reach this cluster from. So given that, we'll move forward and actually launch this cluster. So let's jump out of here and we'll go back over to our web page. We've already selected our region previously, and so we'll go ahead and click Launch Cluster. And from here, it's going to kick right over to Amazon. And because I'm already logged in to AWS, it's going to jump me right over here to CloudFormation, and it's going to kind of start us down this path of creating a CloudFormation stack with the template that we have specified. So you can see here, we're launched. It actually kicked me over to the wrong region. So we're going to flip this and make sure that we're in Oregon. And here we can see that everything else stays the same. Our template file that was referenced on the previous page has been pre-populated. And from here, we can jump in and actually stand this thing up. So again, it's going to ask us to verify the stack name. We've already passed it in via the link we clicked, so we'll leave that as it is and move forward. And here is an option to set some additional tags or information on these instances. Here at Splice Machine in our AWS account, we do have a couple of rules for how we tag our instances. So I'm going to go through and actually add these tags. And so what this does, and tags are an interesting thing depending on how you use and leverage AWS, but the point of this for us is this helps us do cost accounting. So when we put the tags in at this level, every single element that's created by this stack inherits these tags, and then you can go back and see from the EC2 instance all the way down to the EBS volume and even into the VPC itself, everything is tagged appropriately and can basically be tied back to my name here in terms of cost accounting, which helps when you have a large group and you're trying to segregate things. This is not by any means required. It's just a pattern that we follow here at Splice Machine. So from there, we'll move forward. The next thing that's here that's a little bit interesting, and I want to take a second to pause on, is this is a little bit of a summary. It kind of shows us what we just configured. But the key thing here is this little link for cost. What this is going to do, it's going to kick us over to a cost calculator that Amazon hosts over in S3. So let's click this link and see what it shows us. So basically, this is going to pre-populate this form with the services that we have configured in our template. And we can take a look here and see real quick what it's showing us. Basically, it's saying, okay, your compute cost is about $3,500. Your EBS volumes are about $626. And that is a per month cost. And that also assumes that all of these instances are on 24/7. If at any point you choose to stop the instances, akin to flipping the power switch on an actual server, you will not incur the compute costs that are associated with this cluster. But this is a handy way to look at this and see, okay, based on my configuration, what would it cost me to run this cluster 24/7? And then from there, you can start to look into AWS costing a little bit deeper and better determine your usage pattern and what your actual cost would be given a certain cluster and a certain workload. So we'll jump out of that and go ahead and click over on the create button, and we'll get this process started. So from here, this is where we kind of let Amazon take over just a little bit. And what it's going to do is it's going to go on the back end and read that JSON file and actually do the work to create all those individual elements in AWS. This is unfortunately the boring part where we kind of sit here and watch this all go, but we'll keep an eye on this and we'll reload this a couple of times and we can get a feel for what's actually happening here. So if we
one question, Aaron.
Yes.
So when we, how do we, like you showed, we could modify that JSON file. How do we upload it back?
So you would just dump that back up into S3, the same way you would upload a file to S3 for any other reason. And then at that point, you would check that file's URL with an S3 and you would substitute that in the template field in the create stack dialog.
All right.
So we can see here, as we reload this page, this events list keeps updating and it kind of tells us what it's in the process of doing, creating volumes, creating routes and route tables, all the little things that go into putting this all together. And here we can see we've moved forward. Lots of things are complete and we're moving into the creation of the instances themselves.
Aaron, if there are errors here due to any reason, should we abort and restart, or should we continue?
So that's a great question. And actually, we may get the opportunity to see that live. So a lot of things can trip us up at this particular point. And actually, now that you bring it up, we'll take a second and actually explore a couple of those just so we understand them a little bit. One of the most difficult things that happens is we bump into instance limits. So within EC2, so we'll walk away from CloudFormation for just a second and we'll click on this EC2 link and we'll go take a look. So on our dashboard here under under EC2 dashboard, we'll see this little link for limits. This is going to tell us within our AWS account, how many of any given something can we launch. The thing that's very interesting here in particular is the number of instances of a given type. So you can see here, and we'll go right to our specific example, on-demand M4.4x large instances, we are limited to 10 of those. So that's great to know. So if I were to have tried to launch a 10 or 12 or 14 node cluster, we would have failed. Our CloudFormation template stack would have stopped midway through. It would have thrown an error, unable to create an instance, and it would have rolled back all the work that it had already done. And at that point, you've got a couple of options. You can try and augment the stack and relaunch it. For me, what I typically do is I actually just delete the stack, go back and clean up my template or adjust in whatever way is necessary, and then move forward from there. And basically, like you had mentioned, Amit, abort and restart. So either move to a different region or request via AWS support to have my limit increased or what have you to try and augment this situation and move to something that'll actually run for us. So let's jump back over to CloudFormation and see where we are here. All right, so we are create complete. So what that means is everything is up and live. So the thing we want to look at here is you noticed, you might remember that in the JSON template, we had a little section called outputs. And what is that? So what we actually do here is we dump this little table of information. And what this does is now I don't have to go dig through my EC2 instance list and figure out what all my instances are and which one's which and what its external host name is. I've got this little table here that tells me. And we'll see why that's interesting in a second. The other thing that we do here, we actually put a link to the Cloudera Manager URL. So you can, once the cluster's actually up and running, which it isn't yet, we can click on this link. It'll take us right to the login page for Cloudera Manager, and we can really get a look at what's going on the cluster. So to kind of move forward with the next step, what we're going to do is we're going to grab this list right here, and we're just going to copy this. And what I like to do when I'm connecting to a bunch of hosts is I actually like to edit my SSH config file, and that way I can SSH to things with names that are a little bit easier for me to remember than ec2-5471 number.com. So from that, we'll jump over here and we'll actually open up this file. And right down here, you can see I've already kind of prepped a spot to stick all of my sandbox nodes. So we'll do that. And we'll paste this in and we'll see this is a little munged. This isn't quite what we're after here. So we'll clean this up just a little bit. And then this guy. Sort that out. And right here, paste this little bit here. Perfect. All right, so you can see here, and I don't know how many people that are going to watch this really use an SSH config file, but this for me is a lot easier than configuring something like a PuTTY or like a MOBA Xterm to save all these, especially since they change so often. If you do stop these instances and start them back up, the external host name will change given our current AWS config. And then one of the things I do to make things a little bit easier and more consistent is I have this little glob here, and I configure the username, the PEM file for the SSH key, and then a couple other things so that I'm not constantly bumping into issues with my known host file and things like that. So we will save this, and then what we'll do is we'll actually SSH over to all those nodes and take a look at what's going on. You'll notice here I've got this weird sort of terminal setup here where I'm typing stuff in a bunch of windows at the same time. This is tmux. Something I use, especially when managing clusters. I find it easier to be able to connect to all the hosts at one time and see them all at the same time, potentially run the same commands on them at all times. So we will SSH into these guys. This one will be the master. And we'll jump over here, worker 01, super creative names here, worker 2, worker 3, worker 4. Let's see, there we are, and we are not in. Why are we not in? I can tell you why we're not in, because we have a typo in our SSH config file. Let's go back over here. So we are not connecting with Splice, we are connecting as CentOS. Let's try that again. All right, so here we are. We are CentOS. So first thing is, what's going on these machines? So let's just do a ps-ef and take a look. So what do we see? This is the one thing that's kind of interesting, is this user bin cloud init modules, this thing. So basically there's a Python script running in the background, what's going on? And here we kind of dig a little further. We see this post-inst master.sh. If you look at the CloudFormation template for each one of the instances, you will see where we download this file and then we execute this script in that little user data section inside of the JSON. So if we want to see what's going on and kind of where this all is, we can actually tail a log file see, that is, or no, that is in. So we'll just tail both of these the Cloud Init log and the Cloud Init output log. We'll tail them both together. Take a look here, and we can see what's actually going on. So in the process of running these post-install scripts, and these are ones that we wrote that we include in our sandbox setup, we do a bunch of things. We'll go through, we'll install a known version of the Oracle JDK. We will walk through and repartition and mount all of the EBS drives that we created, along with resizing the root partition, which is not done by default with this CentOS AMI and Amazon. And then we'll also install a bunch of sort of packages and configure a few things that are kind of best practices for Linux and Hadoop. Things in particular, making sure that when we mount the drives, we mount them with no A time, making sure that we have NSCD installed, configured, and enabled, making sure transparent huge pages is turned off. Lots of things that these days Cloudera Manager and the like all do check for, but we just like to make sure we get that all right ahead of time. So we can kind of see what this is doing here. Obviously, it's doing a lot of work. You can see a couple of these machines just kicked us out. That is because they have finished their work, and after the Cloud Init scripts run, the instances actually do reboot themselves, and once they come up, they are ready to run. Obviously, you can see here that each one of these machines moves at a little bit different pace. The one on the top that kind of spans the largest section here is the master instance. It does install a little bit more software along with downloading a few additional things. We actually pre-install the Cloudera Manager packages along with its supporting database and pre-download the parcels so that we're very clear on what's here and configured. So it's actually walking through and doing that work now. And once it's done, it will follow on with the reboot as well. Once we see this reboot, we'll give it just a second and we'll reconnect, and we'll be able to see it run through the actual Cloudera cluster setup, configuration, and installation of Splice machine.
So Aaron, currently this is CDH install. In case we would like to make a similar CloudFormation template for MapR or Hortonworks, would these scripts remain common or would they be different?
A large part of them would stay very similar. The installation process obviously would change a little bit. So what we're watching here on this top pane inside of Tmux, the bit about installing obviously Cloudera Manager DB, which is ultimately Postgres and a few other things. That stuff would be different per platform, but in terms of how to automate all of that, I think that there's a process there. It's just work that we would need to do. I have done this in part for Hortonworks. I haven't completed that work yet because I just don't have a good enough understanding of the Embari API to do all of the kind of the final configuration stuff, the things where we configure settings for particularly HBase, but also Yarn and Spark and some of the other supporting services that we use. In terms of MapR, I think the process would be relatively straightforward. I just haven't attempted that yet. Clearly, the creation of the instances, the sizing of the disks, and a lot of the setup work would be the same. I think the thing that has to be done there is understanding the installation process for each platform, and then building out the scripting and automation around that, in addition to the actual cluster configuration itself, where we go in and change, again, HBase, Yarn, Spark type settings to get our system ready to run. So we can see here that the master node has finished its pre-install work. So we'll give that just a minute to reboot, and then we'll try and reconnect here to all of the instances. All right, so we're reconnected. And at this point, all of the interesting stuff actually happens on the master, not so much on the worker node. So we'll take a look here, just run a PS again and kind of see what's going on. So at this point, we can see that Cloudera Manager is up and running, or is coming up, so kind of doing its first boot here. And we'll get a look here and see once we, so we see the database starting. And then once it's up, we can see now that this cluster setup.sh has been kicked off. So if we jump over to the temp directory, do a quick ls here, we'll see a couple of the scripts that got downloaded, a cluster setup.sh and a cluster setup.py. So in this instance, the shell script is a wrapper for Python. The Python script has a couple of dependencies that we want to verify are in place, which is why we wrap it with a shell script, just to make things super easy. And if we take a look at the output here, we'll see that there's a .py.out and a .sh.out. At the moment, we'll take a look at this one because it's going to be the most interesting. So what's going on here? This is obviously some very elementary looking output, but this is kind of telling us what we're doing in terms of actually configuring the cluster. And we'll jump back over to Cloudera Manager in just a minute here. But as we walk through, this Python script basically leverages the Cloudera Manager API, along with a couple of really quick little system calls to get a sense of one, what kind of hardware we have, and then two, it actually goes through and has all of the Splice machine configuration hard-coded in the script to actually push into Cloudera. So what we do here real quick, we look at the amount of CPU and memory we have. That's going to help us gauge our Yarn and Spark configurations. So right here, it kind of spits that out and it says, okay. And then for HBase, we're going to set your HBase heap size to this. We're going to set your Yarn max vcores to here, your Yarn max memory to this. And then, oh, by the way, we're going to configure Spark dynamic allocation to have a max executors of 11. And then we're going to go through, and actually this next bit, installing hosts, is where we're actually telling Cloudera Manager, hey, here are all your machines. go off and install the agent on those, and let's get started actually putting a cluster together. So given that, we'll jump back over here to our web browser, and we'll actually click on this link, see what's going on. So from here, it's going to throw us into a login screen. This is all default for Cloudera. So super secret admin, username and password. And we can see now, not much here. So kind of not a whole lot going on. It's sort of red and broken and you can't really see much. If we look up here, we can see that there's a command running. We can click on that and get a sense of what's going on. You can see here, hosts install. So this is part of the Cloudera Manager setup process. It's installing hosts. That obviously mirrors what we're seeing here in the output of our Python script. So again, this is, again, another part that's a little bit boring. So not a lot to see here, basically paint drying. But what this is doing on the underneath side is saving us lots of clicks and annoyance as we get this set up.
Aaron, can we use these scripts for our regular install also, for CDH installs?
Yes, we can. And actually, a little bit of inside baseball, but for our QA environment and some of our other internal clusters, we actually do have an edited version of the sandbox setup script that we use to verify our configurations match our documentation each time we run through a formal set of tests. And that's actually really nice because then what we can do is as we test on multiple clusters, we can verify that their configurations all match the individual settings and additionally some of the patterns that we follow when we configure clusters. So we do have that available. Couple of things, you could either download what this the sandbox uses, which is up in AWS. If you kind of peek at some of the scripts, you'll see where it is. Or Ahmed on the internal side, if you want to just ping me on it, I can get you pointed at some of the stuff we use internally.
Sure. Thank you so much.
All right. So we can see here now kind of the next piece that's going on. So if it's installed the hosts. And so now it's noting what parcels it has configured. We can see the Splice machine parcel and what version it is. We can see the Cloudera CDH parcel and what version it is. It's going to walk through and do all of the things to push the parcels out to the individual nodes, get them distributed and activated. So we'll kind of see it as it makes progress here to work through this. So here we can actually jump over to the parcels page. And we can, and again, this is if you poke around a little bit in Cloudera Manager, you can actually see the things that are happening. So we can see Splice Machine is distributed. You can see that we're working on distributing CDH. These type of errors pop up. This is what happens when you watch what's going on a little bit too closely. These will clean themselves up as Cloudera has a little bit of intelligent retry logic here as it goes to push things out. So you can see there that it's already disappeared.
So Aaron, right now it's installing 5.6 version of the CDH. Soon we'll be going to have 5.7 as well. Where should we change these things? Would it be the scripts itself, or would it be in the JSON?
So this is actually built into the Python scripts that configure the cluster. As we roll new generally available releases, the sandbox will be updated to support ultimately support the versions of both Splice Machine and Cloudera that we're most comfortable with in terms of having a sort of hands-off sandbox environment. Right now, at the time of the 2.0 GA release, which was earlier this summer, CDH 5.6 was the latest CDH platform that we supported, and that's why we went forward with that one. You can see here now that the parcels are activating themselves as they should be. But given that, there are a couple of ways to approach that. If you wanted a different version, once you have the sandbox stood up, you can follow the normal upgrade path for both CDH and Splice Machine at the parcel level. On our community page, we do have links to the parcels for other versions of CDH. And then within Cloudera Manager, you can obviously specify parcel URLs for different versions of CDH if you choose to go that route. The main goal of the sandbox is to get an up and running Splice Machine cluster as quickly as possible, and really to focus on Splice Machine as a database more so than the underlying Hadoop platform. It just so happens that this was the version we chose to run the sandbox on. All right, and we can see here both of the parcels are now showing distributed in the script output. As the activation completes, we'll see a little bit of a log message there to indicate the same. All right, so we can see there that the activation has finished. We'll see that here that we've got log messages, and then Cloudera moving on with its typical install process. It's running through a host inspection where it goes through and all the way down to the OS level and checks that things are all correct. Things like the JDK version is uniform across all the hosts in the cluster. Things like transparent huge pages is configured, that DNS lookups don't take too long. Lots of interesting things there. And then it moves forward with what they call a first run process, where it actually goes through and initiates generation of all the configuration for the different services and actually starts everything up for the first time. And we can jump back over here and we can see that running command. And there we see first run is running. And if we're really super excited, we can dive all the way in there and kind of look at each one of these steps as it runs through. And so we're not necessarily bound to staring at this textual output in the log file. We can actually interact with Cloudera Manager and see the steps that it's going through. And this brings me to a point where I do want to call out that this automation is far from perfect, and there are certainly ways that it can get tripped up. Once we're at this point, we have instances configured, we have nodes up, we have a cluster largely up and running. If something were to fail at this point, and we were to, for example, see a red X here in this setup sequence that's running, we can actually dig in a little bit to Cloudera Manager and figure out what's going on. Take a minute to see what it disagrees with or what doesn't work, maybe retry a step and actually carry forward. We've done enough work at this point that we wouldn't have to necessarily completely drop the CloudFormation stack and start over. This is at a point now where we could potentially fix an issue if it were to arise. All right, there we can see that the first run completed. We can see here in the log output, first run succeeded. Base cluster setup complete. What this means is that we've installed a vanilla CDH cluster and config along with the Splice machine parcel. At this point, we're going to jump into actually setting up the cluster to run Splice machine. And what we'll do is this Python script will walk through and inspect each one of the services and configure them. And you can see that that kind of runs through pretty quick, tweaking the management service, Zookeeper, HDFS, Yarn, HBase, and then from there, we'll actually restart the cluster. If we jump back over to the UI here, we can take a look and see what's running. We can see we've got restarts of both the management service and the Splice machine cluster themselves. And that is because we adjusted configuration in both of those. And so once those complete, we will have a running Splice machine cluster. So again, we can dig in a little bit further if we're impatient like I am. We can actually get a sense of what's happening right now. So we can see that it stopped all the services, it's starting them up. It'll do those in an order that Cloudera has determined because they obviously know what they're doing here. And they'll walk through and start each one of those services up. So we'll keep an eye on this as it goes.
Hey, Aaron.
Yes.
So if some customer is setting this up, and in addition to the services they have, say they want to include Hive for their whatever purpose they need. So they should be able to specify that in the JSON file, or
So what you would do in that instance is probably just add it once the cluster stood up. I think that would be the easiest thing to do. If
okay.
you wanted to include it in the automation, it would have to be an edit to the Python script that gets run, actually that just finished. And along those lines, we can jump back here. We can see that it just finished updating, or it still thinks we're restarting, so that's fine. But yeah, what you would do there, and so we can kind of come back. So everything at this level is done. The script is just waiting for a couple of checkouts or things that it's checking out before it's happy. What we would do if we were to add an auxiliary service, I think Hive is a great example. You would just go here in Cloudera Manager and choose add a service, and you'd follow through that process the same way you would on any other Cloudera service, or a Cloudera cluster rather. All right, so from this point, everything's up and running. We've got green across the board. So what do we do next? Real quick, I'll kind of walk through that. So we'll break out of this tail of this log file because that's not super interesting. And what we'll do is now we're on all 5 machines at once. And we'll just kind of take a look around here. So the key thing that's interesting, and how do you know Splice machine is up and running? Obviously, the first indication is going to be that HBase is up in green. The second indication is we can jump over to Yarn, and we can look at the running applications. And we should find an application in Yarn titled Splice machine that's up and running. If we drill into this a little bit, so we'll jump into the Resource Manager Web UI. That'll bring us here. And then we'll click on the application master link. Now, this is going to give us a bad link. That's because we're running on an AWS cluster and all of our machines are dual homed. So at some point in this interaction process, the cluster is going to refer us to the internal IP of one of the hosts. And so how do we deal with that? The easiest thing to do is to come back over here, and we'll just grab this URL, the external URL for our master server, and we'll paste that right back in here for this particular instance. We'll hit the return key, and there we are. So now we see our Spark UI is up and running. This is the Splice Machine Spark UI. We'll see here a couple of things going on. What is this? This is part of our architecture where we have offloaded HBase compactions into Spark. This is a constant operation within our Spark context. You'll see these jobs spin up at about a 1 minute interval. If there are no compactions to perform, they will show up as a failed job in Spark, and it'll just keep cycling through those. Obviously, we're not at a point where we have any data in HBase, so there's nothing to compact. And so those will just sit here and kind of cycle, waiting for the next thing to do. But it is there and it's always active. No need to be alarmed when we see a list of failed jobs, as long as they all say that they're reserved slot for compaction. Obviously, when we get into loading data, running queries, those types of things, we get a little bit more focused in on exactly what's running, what succeeded, and what failed. So given that, we'll jump back onto our terminal here for just a second. One of the things that we do want to take a look at, if we jump into the HBase log directory. So this is kind of where we get a little bit of a sense of what Splice Machine is doing. And there's two things that are interesting to look at here. One is the Splice Derby log. That log is going to be SQL information. So as we execute a query, if it returns an error code, we can dig into this log and see a little bit more about what's happening there. And that's really what that log is focused on, is that sort of SQL context issue. So if you run a statement and it throws a syntax error, you might be able to get a little bit more detail than the error message in this log. If you run an import command and it fails with something that's not so clear, you can dig in there and see why maybe the procedure call was kind of returned and said it didn't work. Maybe there's something in the command that might be a little mixed up. On the other hand, there's the actual HBase logs themselves. We're going to take a second and look at those logs real quick and see what's interesting there. So if we jump down to the bottom of these logs, and what we can kind of see, you see across the bottom on all 4 of the region servers, the last line looks pretty similar. We're going to dig into that one just a little bit. And let's see. Come on. There we go. So this is the thing that tells us that Splice Machine is up and running. And I did want to take a second to call that out. It's really nice and clean, really lets you know that the database is up and, as it says, ready to accept JDBC connections. So given that, we will jump out of there, quit all these log files, and how do we get connected to the database? So the easiest thing to do is on any one of the region server nodes, we can just log in as any user and run SQL shell. If I could spell it. And what that'll do is connect to the database. It's going to use a default username and password that's included in this script, and it'll get us connected to the database. From there, we can issue some simple commands, kind of explore what's going on. So we can say show tables. What am I going to see? We're just going to see a list of all the system tables. And at that point, we're interacting with the database. Obviously, this is a command line, not the greatest thing in the world, but it's a good way to do some quick interactions with the database. If we're going to initiate a bulk load or some other things, start this script up in a screen session, and you can do some long-running stuff without having to be tied down to the cluster. Other ways to connect, any standard JDBC client will work. If you want to grab the driver jar, that's where things get a little bit interesting. That driver jar is included in our installation. It's on every node in the cluster. Specifically, it's going to be buried in the parcel that we actually install. But let's take a second and look at where that is. So that's going to be an opt, Cloudera, parcels, Splice Machine, lib. And inside this lib directory, obviously there are a lot of jars here. The one that we're interested in is the DB client jar. And so from here, you can just SCP this jar off of the cluster, put it into a spot where you can actually get to it with your local machine. And then at that point, you can use that and configure something like a DB visualizer or dbeaver or any other kind of JDBC client that you might want to use to connect to the database. That kind of terminates what we're going to do here today. I just wanted to show how that gets up and running. I hope you guys find this thing useful, and please reach out to us via our community forums or on Slack and ask questions if you have them. Thank you.